Good afternoon, this is Hallicrafters Rehabs, and welcome back. We are now ready to tackle the RF section. I went ahead and put in the first RF coil, which is really a form with two coils on it. One is band 1 and the other one's band 2. And they're installed right here with a screw and nut, which was a little bit tricky, so I went ahead and did that ahead of time. So just because it's a time-consuming thing to do. So the first thing is we have to connect band 1 to the switch, and I've prepped all the switches, connections, and things like that, and all the components. This is the RF section. So in the RF, see if I can find the pen. Yes. And something to mark on. So, if your oscillator is tuning in on the band, let's say this is the band, and these are the markings. Your oscillator will give a signal, we'll say like this, pretty sharp, what we call as a sharp cue. Then you want the RF to be aligned with that. Let me get the, here we go, the main tuning capacitor, without knocking it on the floor. Alright, this is actually a band spread. It'll work. It's not the main tuning capacitor, it's a band spread, but it's easy to work with. We'll pretend. So, this would be the oscillator, that would be the RF, and that would be the antenna. So in the early days, these were separate tuning capacitors, but now they're ganged, in the sense about the mid to late 20s. And so the RF tracks with the oscillator as well as the antenna. But the RF this is the RF tube right here. It comes in through the antenna coils, and then to the RF tube is amplified like this. So this is your RF tube. There's the plate coming up, and then you have an RF coil which goes to the B+. And there'll be trimmers like, I think it's like this, so forth. And that is your, acts like a preamplifier, or it actually, go back to my other picture here. Here we go. So RF, in terms of RF, if this is all the signals in the world coming through this antenna from very, very low frequency all the way up to microwave. But they are all attenuated here by a coil that only resonates in a small region of the band. Less narrow than the oscillator, but still a small region. So when you're aligning the radio, this will be typically at the top end, we'll say 1400 kilohertz. And then you peak also the RF trimmer capacitor for the maximum response. Now, over the whole band, you may get different response. So if this is 600, this is 1400, most instructions have you do the RF over here for the maximum signal, or whatever frequency that is. But there's another response, which is, if I were to peak it here, it might go up to here. So, as you go along, or it may be only to here. In fact, the way radios really are, is it decreases with frequency. Ideally, you would peak it down here in some respects, but they don't, because, for a lot of reasons, which we don't need to get into. But the overall RF response, you know, wherever you peaked it with the signal will be different. And what I normally do is I look for the stations I'm interested in and will peak it generally somewhere in here to get more response on the low end. But I sacrifice a little bit on the top end. So the RF is not nearly as precise. All I have to say, the RF is not nearly as precise as this oscillator, which allows you to have more latitude in lengths of cables. All that explanation was to say that. So, and that's what we're going to do. So we're going to connect the switch to this pin, which is B. I've already looked at my parts receiver. I really should do a blow up of the RF so I can show you what's going on here. So we'll just wrap this around and I'll go get a blow up and print it out and we'll take a look. Okay, I'm back. So here's what we're looking at. Here's the RF amplifier tube. It's cut off here, but that's basically the plate resistor right there. Goes to the switch. Then it goes to the 4 coils. First is L4, L5, and L6 is 2 bands. L6 is 2 bands. This is band 1, that's band 2, that's band 3 with the trimmer, and that's band 4. And it's a nice day outside with the sun out. So what we're going to do is we're actually going to wire this one to B first. It goes to pin 2. That's and then we'll wire this yellow one to pin 1, and then we'll do pin 3 to here and pin 4 to here. And A, B, A, and C are all connected together. Here A and B are together. When we get the other ones in here, you'll see that. Alright, so I twisted that around. And now we can go ahead, and this is already run through the trimmer capacitor for band 1. We don't need to seismically qualify it, we'll just bring it around enough to hold it mechanically long enough to solder and get ourselves some more solder. So, band 2 to B. RF is a lot simpler than the oscillator. There's very little of this A is what is B is very simple. One thing we need to do is we need to check these, and I didn't do it. So let's go ahead and do the inductances and so forth for these bands. So we're in the RF section. And 6. Tell you what prompted me is that seemed like a really loose connection there while I was doing the soldering, but it had a lot to do with the fact that that solder iron was hot. So, C should go to ground, so we'll just connect ground right here. And let's see what we can come up with. And first of all, band 1. Okay, that's 20 microhenries. My pen disappeared while I was moving things around. That's B to C, 20.8 microhenries, and the resistance, 1.5. That's a DC resistance. All right. Then we'll take a look at band 2. This is, sorry, that was D. Yeah, there we go. This was not B to C, it was D to C. This is B to C. And that is 1.4 ohms. Just to document it, because nobody has ever done it. 20.8. Well, that's really interesting, isn't it? They're essentially the same, but they're not. Yeah, B to A is the same thing as B to C. There may be some interaction going on with that trimmer capacitor, which is now in the circuit. These again were rusted, and they were cleaned with evaporust. Not exactly that. Well, at least we have continuity. So we'll do this before we solder everything into band 3. So we'll first do A to B. So B is actually a ground in this one. And that's 3.2. So this is L5. And it's B to A. And the resistance, 0.2. All right, then let's look at this is actually the secondary side. Let's look at the primary side. The first two bands don't have a primary, they're just simply a coil. So this one is going to be D to C. Here's C. And here's D. .9 ohms, 7.8 ohms. Alright, 7.9 ohms. And quite a bit different, isn't it? Okay, and then you can put that one in. And a simple Phillips head. Move this around here. The notch has it going this way. Now, we'll talk about that capacitor in just a second. It's between So, this capacitor. Now, I told you this was a full B plus on this side. That's the characteristic of an RF section in the radio, is that you have B plus across the coils. The antenna, there's basically no voltage. And the oscillator, there is a reduced screen voltage or something like that. But your highest voltage is right in this area. So, here's the 2.2 picofarad. It actually measures more than that, maybe 6 or 8 picofarad. I'm not going to change it out. There was absolutely, this is ceramic capacitor. When you see them like this, and there was absolutely no leakage whatsoever in that capacitor. So, why do I want to worry about changing it? Especially, it's hard to really, I mean, you're not going to make it more precise or less precise by changing that around anyway. So if it's working, it's good. So there are 4 connections on this one. There's B. And here we go with that, this little trip here. Anyway. So, A, B, C, D. So B is a ground, and it connects to A in on the switch. Let's see. Looking careful. B, okay, connects to A over here, which is this connection right here. It goes around to, it's also connected to the ground here. Although you don't see that on the schematic, that's one of the 2 leads. And I've got this down here. It's a little tricky. Let's do this. It goes on the other side and connects to the stator of the main tuning capacitor. There are 2 wires that go through this. This is one of the 2 wires that I've set up to do that. So it's coming around on this side. Let's see if we can get that moved. There's a little bit of close over to this thing. Here. It's an undocumented wire actually in the schematic, because the schematic is simplified. It shows just the ground. It doesn't show that there's a ground wire. There's nothing wrong with the schematic electronically. It just works better. It's what the operational experience technician said you needed to do to get rid of something in the prototype. Sorry, I have to put my head in here to see what I'm doing. I'm just simply wrapping a wire around so that it solder nicely. Nothing more. Alright, so ground on D in this coil connects to ground on B in this coil. Now C connects to a resistor and pin 3 of the switch, which we may not have this right. One, two, three. That's too short. Alright. Just D. Alright. So what we're going to have to do is move this up, and we're going to remove this. For some reason, the microphone was unplugged. I do apologize. Let me plug the microphone in. Okay, forgive me. I fixed the audio problems, and then we lose all the audio because the audio was not plugged in. You have to unplug it to get the memory card out and tear everything apart, and then you have to remember to put it all back together exactly right. That's a little too much for me. Okay. Still continuing on the RF. There we go. So this is high voltage. Goes to pin 3. I hate it when this thing cuts off. What you see is not what you get. Let me study this a little bit. Is that interesting? Not a typo, just another situation where the confusion is created by the drawing. This 6800 applies to that resistor, R6, of course. It's written all over this wire, so every time you look at it, you're looking for a resistor here, but it's not. That is connected directly to B+. That's this thing, and we'll connect it directly to B+. Man, is that tricky. So, I did have it right. This goes in here, and we'll just do a connection from here to here. Man. I don't even know what I did with that wire. Could use it again. It's already stripped, but I can't find it. Tell you what, we'll use a new strip of wire. Again, that will be a clue that that's high voltage. Is this wire? This in here? This is not the first time, that's the first. Oh, part of the confusing when I did that. Is this in me? Did I have anything wrong? It's not here. Okay. Everything stands here. Here. Sure. This is the connection to the switch again, which is position 3, 4, 5, and 3. This is how I learn. All right, fresh, clean, silvery solder connection. Okay, that's trimmed. And we're ready for band 4. And this is what I don't like right here. This kind of, well, we got a spare place to hook up a connection. Let's see. So we're going to clean this off, and then I have put in a terminal strip down here to relieve that of all this nonsense. So I'm going to do that off camera. So we'll be back. Okay, what we have here is a cleaned up band 4. Let's do a little bit of dope on it. Band 4 RF coil. I have already ohmed it out and taken the measurements for the inductance. Always does a nice job of making it look like it was built yesterday. It doesn't hurt at all. It's like coating it with clear plastic or polyurethane or something, except it's designed for coils. About 5,000 volts or something like that of breakdown resistance. Alright, so we can put this, see the key is that way. Here's the Phillips head screw. Put this around. There we are, in place. So, that's A, B, C, D. So for A, that's a ground. And that is one of those blue wires I've been putting in, which goes around to the stator of the main tuning capacitor. So we'll just go ahead and do that. Nothing more like that. You sit through right there. Comes right under. Don't do that. So, on top. We'll keep this select as clear as possible. Okay, sorry. Running through, nice and silvery. Okay, so B goes to pin position for the switch, which is this fella right here. And we don't need to make it so long. Need to give me, I think I've got the old beat up strippers instead of the new sharp ones. There we go. So that goes to position 4 of this side of the switch. Nice and silvery. Trim that off. Remember, we're in the RF section, not the oscillator, so a little extra wire is not going to make that much difference. And then C goes to D. I believe C is this one. Let's go ahead and put this onto D. Nice and silvery. Now guess what we're going to do. Now that's the B plus right there. I'm going to move these out of the way a little bit. I'm going to bring it around to here, and that's going to be what we hook on all those components to for B plus later. Alright, there's a 2200 picofarad capacitor from the old system, and we're either going to keep it or we're not. So what I want to do is check for leakage. This is on the B plus. It can absolutely not leak. So we're straightening this out. Okay. And let me get my leakage tester. My Mr. Carlson's Lab early version of capacitor DC leakage testing. Set on mica. It's ugly, but it works. So I'm off. Just get a good connection there. Okay. And we should be seeing this thing charge up. Not to be found. That is a leaky, unacceptable mica capacitor. It's gone. That should have, the light should have gone out within a few seconds for a 2200 picofarad. Just curious. Testing it on here. Oh yeah, 2500 picofarads. Well, guess what? It's probably 2200 picofarads, and the current that doesn't go away is raising it to 2500. So just because it raises, if it's going up in capacitance, more than likely it's also turning into a resistor. A mica capacitor that's a resistor. Okay, let me go find the part for this and I'll be right back. Guess what? I was not planning to replace that one. And I didn't have a new one. But here's one, exact same replacement from another unit. And it's 227 picofarad. And watch the difference in the leakage. I got this in here. And gone. Just like that. Perfect. So we're going to put this one in. How about that? So I lucked out. I didn't actually include 220s in my order, right? At least or I lost them, one or the other. That's always a possibility. So it goes to position 1 along with the 6800 ohm resistor. Okay, we gotta go find those, so we'll be back in just a second. Okay, well, let me test this. I finished what I need to do with the RF, and then after that test I'll explain what I did. So this is in band 1. There's a 22 ohm resistor, plus it goes through I don't know, here we are, 1.5 volts, so that's 23.6, okay, 1.5 ohms coil resistance to get to B+. So then band 2, we have 7.9 ohms plus 22, so 30, pretty good, huh? Then band 3, I think I went the wrong way. Okay, that's the, now we have the 6800 ohm resistors, and they actually measured about 65 or so, or something like that. So there's the band 3, wrong way, and band 4. I'm upside down and backwards to figure out the band. So there's band 3 and band 4. So what did we do? Turns out that my terminal strip was not big enough for all the things I wanted to do with it, to get rid of that mess on top of the coil. If you look, it's cleaned up around the coils. This one's not, I'll solder that one. It's cleaned up around the coils, and so you have no issues in getting access and things like that. You can still get in and clean the switches, and you can easily remove. Now I put that working mica in here that doesn't leak next to the 6800, which is what's in the schematic for L4. This is 6800 somewhere down here somewhere. Between it's here from 1 to here, plus a 2200 there parallel. I don't like that arrangement, but that's what it is. And here's the second 6800 here, between pin 2 and 3 on the switch, and then you have the 2.2 picofarad, and then 4 goes directly to the coil. And on the other side, you just have the trimmers and the connection to the switch on the rear side, which is configured properly because it's working. There you are. If it works, therefore it's configured properly. And I put in a 1, 2, 3, 4, 5 terminal strip here. This is not soldered yet because we still have to bring B+ to here. Then this one is for the 25 ohm that'll go to this thing. I could probably put that in there. And then this is the 22 ohm, which is soldered, which goes to the plate, which is up here. I think I'll go ahead and put that one lead that goes from there to pin, hard to read. Yeah, it's pin 8 actually of the mixer. Right. So pin 8 is right here. So I could put a green lead, which is green is to the grid, signal grid. And this needs to be as short as possible. So we will take this, strip it, and twist this to give it a nice twist, and bring it through. We can move these out actually, so I can get there. These are not soldered in place yet. These new recording resistors just don't have leads that the old-fashioned ones did. So you kind of have to make this back in the day. They just made everything was 120, so they just made one enough. So the lead is right here. There's that now. Everybody's neat twisting. The fingers are just not right enough. I need to change this one. Okay. And also narrow ones. Nurse? Narrow beam nose. Yes, doctor. Yeah, we like it. Teach you. Much come over, just stand next to me with the tools, and don't try it. Yeah, don't try it. So I use the tool before I do any of this work, just perfectly, and then when I call something, you just pop it right into my hand. Speed is the essence of the word. Speed is very important, right? Okay. Enough talk. Enough talk. Alright, so this is not going to solve yet, folks. We have to bring the device. Just bring this right into the full device. Alright, RF is complete and tested. Oh, let's go ahead and do this, these slugs. Only 2 slugs in the RF. The slugs are for the transformer-like configurations, bandpass configurations, and are not on this band 1 and 2 coil. And they come with a little string thingy. This is officially called a thingy. It goes right next to the slug. And that gives us, it's just going to go in more easily because I don't have junk hanging over it and around. Get my narrow screwdrivers around here somewhere. Came right out. Let's get there, narrow screwdriver. That's not it. That's it. Came right out. So let's get it all tangled up and lost down inside. Alright. There we are. Maybe. My fingers need to be about, I need small hands. I have fat hands. No comment. Alright, this one goes in here. A little string thingy. And right up is ready to go. And I'll probably cut some of this. Take this little bit and I'll do this kind of thing. Yeah. We'll just get this inside so perfectly. There, it's supposed to be twisted. Careful, careful, patience. These are very delicate and they do break. I could at least take one or two started. I may have to do that. The whole reason I mentioned I started that on control. If this doesn't look that's what we're going to do. I had it. I have it here, right? Well, please just hold it in place. I'm going to have to start. Set it backwards. I'm going to have to start the screw. Don't need anything more. That's super good. There we go. And relax. Alright, back in. Place, slide side towards you. Insert, rod, inside. With fresh tape. Cut the faces. Left leg, inside. What was that? Come on. Similar angle. Yep. That was the trick. It does have a funny little shape to it, but electronically has no idea it has a funny shape. That's a long enough tape, so we're going to do antenna next time. I've already got the antenna connections in, and I coated the little labels here with coil dope. Looks really sharp. This is Hallicrafters Rehabs. Thanks for watching, and thanks for all the new subscribers.